So we're going to configure VSIX1 with security settings. We're going to implement these specifications that are listed up here. I strongly encourage you to watch part 1 of assignment 54 because it demonstrates the security settings in action. The most interesting specification here is PC4 that we have down here. I'm actually in PC4 right now here. And PC4 is able to fetch a web page from our web server on PC2, but we are not able from PC4 to ping PC2. You see that here. So we will look at how to configure the security settings on VSIX to achieve, for example, this requirement for PC4. When I talk about security settings, it's actually quite literally. I'll bring up the original configuration for our VSIX1 from assignment 11. And this is the security configuration part. If I click here behind the curly bracket, we can see here marked in red, this is the entire security configuration part right now from assignment 11. So we will be building here on the security configuration part from assignment 11. We can see that our interfaces G001, 2, and 3 over here on our VSIX1, they are all in the security zone MyTrust1. That is what I have called it. And we have one policy, and the policy is from zone MyTrust1 to security zone MyTrust1. Only one policy and one zone. We will together here do the security settings on VSIX1 in order to achieve the security specification listed up here. Before we look at the configuration of the security, we will have the theory behind configuring the securities. Let me move workstation out of the way. Here we have our VSIX with G001 here, G002 there, and G003 there. These are the three interfaces that we are using on our virtual VSIX here. I have made a principal block diagram for our VSIX that I'll bring up here now. Here we have G001 there, G002, and G003, and G015. So this box here represents all 16 interfaces. When we unbox our SRX, or when it is reset back to factory defaults, all interfaces, as shown here, they will be in the so-called security null zone. This means that the interfaces are locked down. Nothing can go into an interface or come out of an interface. In order to configure the interfaces, they must be brought into an active security zone. And you can see here that I have symbolically with this box here indicated that this is my MyTrust1 zone, as we saw over in our configuration. So we had it here in the zones part. We had the security zone, MyTrust1 zone. So that is what I have drawn symbolically down here in this box here. And we have G001, we have G002, and G003 in that zone. Let us graphically put these interfaces into the MyTrust zone 1. So I'll do that here. So this here now corresponds to our configuration here. G001 is in security zone MyTrust, G002 and G003. And now that we have G001, 2, and 3 in a security zone, what we are going, you and I together, to configure is what traffic do we want to allow to transit from G001 to G002, from 2 to 3, and from 1 to 3, the transit traffic between these interfaces. That is what you and I are going to configure. For example, traffic coming in on G003, what traffic should be allowed out on G002? We saw that ping traffic was not allowed out on G002. We have seen that HTTP traffic is allowed to transit from GE03 to GE002 and out on GE002. That is from PC4 to PC2 in this case, and vice versa from G002 the way back out on G03. That is from PC2 back to PC4. That is the example we have seen. So this transit traffic here is allowed. How do we configure that? We can put that in another way, that HTTP traffic is coming in on G003 and is going into the routing process and is allowed through the routing process, and the routing process decides that this traffic has to go out on G002, and that is allowed. It's going over to PC2 as it should. And what it is that is allowing this traffic to go through is the so-called policies. A policy is what you and I will configure here, and it is the policies that decide what traffic will be allowed to transit from one interface to another interface, in this case from G003 to G002. Obviously, the policy that you and I are going to configure will allow HTTP traffic to go from G003 to 2, and it will not allow ICMP, i.e. ping traffic, to go from 3 to 2. That is what you and I are going to configure in the policy. We are only going to configure one zone here in assignment 54. So I have brought up the configuration here that will implement the specifications that we have over here for the 4 PCs. And it is the configuration for our SRX1. We see the policies section here, and I have graphically over here in my graphic shown with this box the policies. There's only shown one policy in here for interfaces in the trust zone. And we are in the security section of our configuration over here. We have a set of policies that define the policy from one interface in the My Trust Zone to another interface in the trust zone. We have 2 policies. One policy is here and the other policy is here. Actually, we have 3 policies as we have introduced a default policy here at the end. The overall structure of the policies evaluation here is that we ask the question, if we have a match here, then do permit in this case. Else, if we have a match for these conditions, then again permit. And else, if we do not have any match for our 2 policies, then do the default policy, which in this case is a deny all transit traffic. We have named one of our policies a relatively long name here, allow ICMP from sensor and server lands to any destination. That is a name that we came up with for our policy here. The other policy that we have is named allow sensors and PC4 to access HTTP servers. Our match condition have to be understood as and conditions. So what we are asking here is like this. If source address is from the sensor or server's LAN, and if the destination in this case is any other networking device that we can access, and if it's an ICMP package, then permit. The important thing here is to realize that those here are and conditions. All three conditions have to be fulfilled in order for the then to be executed, i.e. for our traffic to transit based on this policy. If one of our conditions in our first policy here failed, we will go on and evaluate the next policy. So if the source address is from sensor LAN or PC4, and if the destination is our web server, and it is HTTP traffic, either to port 80 or to port 8000, then permit the traffic to transit. If none of these two policies evaluated true, then we will go on to the default policy, which will deny transit traffic from the interface in the MyTrust zone to another interface in the MyTrust zone. When I say an interface in the trust zone, what I actually mean is, for example, GE002, which is in the trust zone, the MyTrust zone 1, but it is actually a subnet that I'm allowing traffic to transit to through that interface. Let us together look at a frame as an example briefly that will go through this evaluation process in our policy. The GET request here is originating from PC4, and the destination IP address, or the destination, is our web server PC2. We are requesting a web page from port 80 on PC2, and the source port on PC4 is 45123. We see that it is a GET request to our PC2. Our IP packet here will be evaluated over by the policies from top to bottom. And the first evaluation will be, is the source address from the sensor and server LANs. Note the IP packet is originating from the actuator LAN, the 13 network. This means that the evaluation already failed, and we will move on to the next policy and the next match question, the next match condition. Is the IP packet originating from the sensor LAN or from PC4? And yes, indeed, the packet is coming from PC4, so that is fine. Is the destination address the web server? And the destination IP is indeed our web server, PC2, so that is fine too. And is the application layer for what is called junos-http or my-http. This is for port 80, and it's the HTTP protocol that is being asked about. So yes, source address and destination address and application layer protocol, they are all approved. So this is a permit, which means that this IP packet that we have here can transit from GE003 to GE002. This means that our policies over here, they are allowing traffic that comes in on GE003 to transit over and out on GE002, which is our server LAN subnet. It is the policy that allows this transition. We have the policies, the actual policies over here in our configuration. So you will have now to type in the entire security policies section here into your assignment 11 configuration. There are quite a few things that we have to talk about more regarding what is listed here in our policies. Here we have the sensor and server LANs. Where is that coming from? We have the junos-icmp-ping match condition here. We have sensor LAN and PC4. Where does that come from? Web server, where is that defined? And we have these two protocol things here, junos-http and my-http 8000. This is a so-called Junos address book going from here to here. And you can see here that here I have defined the sensor LAN as being a subnet, the 10 subnet actually. Likewise, I have defined the server LAN as being the subnet 11, And the web server is on the address 11.2, and you specify that this is the actual address. By further we define address sets. We can call this address set sensor and server LANs, which we are using down here. And the address set sensor and server LAN consists of the sensor LAN and the server LAN, and they were defined up here. In this way, we built our address book to support our security specifications that we have listed over here on the left-hand side. We have defined the address book to be global, which means that it can be used anywhere in our configuration. So it's time now for you to enter the address book also. Down here we are using the junos-http pre-configured application layer protocol, but we are also defining our own HTTP application layer protocol here with port 8000. And the custom application protocol definition takes place in the applications layer section of the configuration. Let us collapse the zones. Down here we have at the end custom application protocols defined by us. And we have defined the my HTTP 8000 application layer protocol here. So the application layer protocol has to be HTTP. It has to be using transport layer TCP protocol, and the destination port has to be port 8000. This is what allows our PC4, in this case PC4, to access the web page on port 8000 on our PC2 web server. This finalizes our walkthrough of the security settings for the security specifications that we had over here. We have only configured one zone in this example. Obviously, we can put our interfaces, i.e. our subnets, in multiple zones to fine-tune our security settings on our SRX.